Life is like mathematics. If it goes too easy, then maybe something is wrong. Good day everyone! Hi, I'm Rose. I'm Kay Anatabag and welcome back to Find K, where every K is a lesson that counts. So we are back again with another video where we are going to nourish our minds with another K about methods of proof. Well, for our previous videos, we have already discussed about methods of proof, remember? We had trivial proof, vacuous, direct, indirect or proof by contradiction, proof by contrapositive, and proof by cases. But now, we are going to dig deeper and just focus on proof by contradiction, okay? Specifically, I will demonstrate on how proof by contradiction can be used to establish one theorem on sets. So, let's go! Okay, so we have a whiteboard here. But before we start, just a recap to establish everything. A proof is a valid argument that establishes the truth of a statement, whereas a theorem is a statement that can be proven to be true using definitions, axioms, other theorems, and rules of inference. So let's start by having this as an example. Okay, so in this problem, we are going to prove that an empty set or null set is a subset of every set. So again, we are going to prove that an empty set is a subset of every set. Some people would say that this is vacuously true. And guess what? Those people would be 100% correct, since we can just say that this is vacuously true and just accept it. But I want to give a proof that is different and perhaps simpler so that you can grasp the whole idea of it. So let's prove this using the proof by contradiction. So when we say proof of contradiction, from its root word contra, we are going to oppose, to go against with, or to contradict with the idea. So since when we say that we are going to prove something by contradiction, we are technically going to assume that what we want to prove is not true and that the consequences of this are not possible. So for this problem, let's say that an empty set or null set is not a subset of A. So what does this mean? First, in order for an empty set to be a subset of A, this means that every element in the empty set is also in A. But when we say that the empty set is not a subset of A, then this means that there is an element in the empty set that is not in A. To put this in symbol, there exists an X in the empty set such that X is not in A. So let's contemplate about this one, especially on this part. Is it correct for us to say that there is an element in the empty set? Well, that's absurd, right? Because we all know that empty set contains no elements. Therefore, we could also say that there is no element that is not in A. And with that, we just had a contradiction. Therefore, we have just proven that indeed empty set is a subset of every set. And congrats, because that's our K for the day. We have just proven that indeed that an empty set is a subset of every set using the proof by contradiction. Well, actually, we are going to end on this note. But since last month, I have been receiving requests and comments about sets. And since I love you guys, I want to end your confusion by answering some of the misconceptions about it. So let's go about sets. Are you ready for it? Of course you are, right? Because you want this. So let's clear your misconceptions before they turn into your mistakes. Ding! Welcome everyone to our extra discussion, which is obviously about sets. So let's start by first defining what is sets. So sets are represented as a collection of well-defined objects or elements. But I will not dig deeper onto the definition of terms since I know that you have learned already it in grade 7 or maybe up to college. So for this video, I will just focus on the misconceptions about sets, okay? So let's start by having this as an example. Okay. Okay, so look at this. Is it complicated? Well, I guess it is, especially if you already forgot the basics about sets. But don't worry, because I will give you 3 points to ponder in order for you to answer this problem correctly. Okay, so if I'll ask you about how many elements does this set contain, are you confident with your answer? Well, maybe now your answer is probably n equals to 8 or n is equal to 7 or 6 or 5 or so on and so forth. But don't worry, because look at the sets. I will give you my first hint. Okay, so take a look at this. Are they the same? If your answer is no, well, that's good, because this and this are not the same. Because this is just a null set, but this is a null set inside the set. So they are different from each other. So for my first hint, this and this is not equal to each other. Okay, so take note of that. For my second hint, that repeating elements inside a set are only counted as one. So take a look at the elements. So since we already know that this and this are different from each other, then obviously they are repeating elements. But take a look at 4. You have 2 4s, right? So we'll just cancel the other one and just take this. Okay, so we have only 1 4. Okay, so for my second point, repeating elements are only counted as 1. Remember that. Well, maybe you have already changed your answer, right? And that's good because you've got my points. Okay, so for my last hint, set inside a set is only counted as 1. Okay, so set inside a set is only counted as 1. So take a look at the elements. So we have this, this, and this as the set inside a set. So but let's just focus on here. Did you count this as a 1, 2? Or maybe probably 1, 2, 3, 4, 5? Well, it's okay, because right now at least you know, right, that this set containing 2 and 3 as elements is only counted as 1. Okay, so do you have your answer right now after incorporating what we have learned or my 3 hints? Well, let's rewrite it. Okay, so we have this and this. Okay, so we have 4, 1, 4 only. We have 5. And we have the element, which is the set containing 2 and 3. Okay, so let's count. 1, 2, 3, 4, and 5. So our final answer is n is equal to 5. Did you get it right? Okay, that's very good. And that's okay for the day. We have learned that this and this are different from each other, that repeating elements are only counted as 1, and that set inside a set are only counted as 1 also. So, but if you're probably asking, or if you're wondering how about if we alter or rearrange the elements inside a set, will it just be the same? And the answer is yes. Well, if you have written that the 4 in the first part and this in the last part, or vice versa, or whatever did you like, or whatever have you written it, well, that's okay, since that's the same. And that goes to our fourth point, which states that order in sets does not matter. That's it. That's our key for today. Thank you everyone for listening and for being with me for this video. If you have questions or queries, you can write down it in the comment section, or you can just PM me on my Facebook account at @KAnatabang. So thank you once again. I love you to the infinity and beyond. Thank you, Ma'am Rose, for listening and for your great consideration about this video. So thank you so much. Bye-bye.